Hello everyone, welcome back. This is a Calculus 3. In this video, we are going to talk about 2.7 cylindrical and spherical coordinate system. So let me show you the concept, what that cylindrical coordinates and spherical coordinates are. So just recall, if you guys remember the Cartesian coordinate system in two-dimensional space, actually it provides a straightforward way to describe the location of points in the space. So for example, XYZ, this is the, Cartesian coordinate system, correct? And then we know how to read the points X, Y, Z. This is the position from the X-axis, Y-axis, and Z-axis. So if you have the number, you can point out where it is located. So that's a Cartesian coordinate system. So we learn in chapter, I believe 1, we learn how to convert Cartesian coordinate system into polar coordinate system, because this position also can be located by reading the angle, and radius in terms of the circle. So it's happening again in three-dimensional space. You can find out the location of XYZ in terms of the radius and theta and whatever the other variable from the z-score. So this is we call actually cylindrical coordinate system. So I'm going to show you in this video how to convert from the Cartesian coordinate system to polar coordinate system, or it is a back and forth. And then, as I mentioned, we are not only talking about the cylindrical coordinate system, we're going to talk about also a spherical coordinate system. So in this video, we have two systems to locate the same position of Cartesian coordinate system. One is a cylindrical coordinate, another one is a spherical coordinate system. So in this video, as you see that, this is the coordinate cylindrical coordinate system, and I will show you later spherical coordinate system from Cartesian coordinate system. So we're going to show you how to convert back and forth. Okay, so all you need to know is a little bit of the information we already talked about in chapter 1. We learned that x is equal to r times the cosine theta, if you guys remember the characteristic of the right triangle. Y is also same as a radius times the sine theta. And then z, we are not going to touch here, even though it is a three-dimensional space. It's going to be the same z. Okay, so that's how you're converting from cylindrical to rectangular, because you can convert whatever complicated, r theta z by using this information. You can go back to x, y, z, correct? Likewise, you can convert back and forth from rectangular to cylindrical. So we know that, x, a little bit of typo. This one should be r, right? So r is equal to radical x second power plus y second power according to the circle equation, and then tangent theta is a y over z, y over x, and we don't touch as nothing. So here we are talking about the three-dimensional space. You are going to convert x, y, z to r theta z, or this is the cylindrical coordinate system, and then I'm going to show you also convert to spherical. It's a little bit different symbol, but I will talk about that, too as well. Okay, so that's all we're gonna do in this video. Let's do the work step by step. Okay, so what we're gonna do in the next slide, I'm gonna go down a little bit of recall, right? Recall. So in the first image, what does it mean? We are passing through the x-axis. So this is the plane that we are passing through, x equal to some number. So that means that this plane is going to be parallel line with xz plane. Just to remember. So if you have x equal to some number, so we have, we have x, y, x, y, z, and then I'm just, trying to graph x equal to some number. So we are passing through the x here. So this is the graph x equal to some number. This plane is going to be parallel line to YZ plane, because YZ plane, if you remember the characteristic, this is means X equal to some number, right? So they are parallel line to each other. Same thing in the second image. If you have a plane that is passing through the Y, right? So Y equal to some number means it is a parallel line to XZ plane, correct? The last one, if you have a Z equal to some number, this equation is a parallel line to XY plane. Just be aware, we talked about this one. And then we're going to talk about later, convert, XYZ to R theta Z in terms of the coordinate system. So you will find out more three-dimensional space in the cylindrical coordinate system. Okay. So all you need to know is just keep in mind the same information we learned in chapter 1. So let's take a look at the example. The question is not that complicated, so that we can just go. So this is a recall slide. All right, let's do the example 1. Plot the point with cylindrical coordinate. So this is a cylindrical coordinate that we have. This is R theta Z. Okay, so R represent the radius, 2 pi over 3 is the angle, and then -2 is the Z from Z axis. I want to convert it to the rectangular, the Cartesian coordinate system, correct? So here, that's what they're indicated. This is a location of 4. The radius is 4. The angle is gonna be 2 pi over 3, -2. So it's hard to imagine it, right? So let's convert it to XYZ Cartesian. So we know X equal to R times a cosine theta. So R is 4. Cosine angle is 2 pi over 3. So if you simplify using decimal, you can find out -2. So X is going to be -2. Y is R times a sine theta. So 4 times sine 2 pi over 3, you will get 2 radical 3. And then Z, it's the same as -2. So what does it mean? 4 2 pi over 3 comma -2. This is the cylindrical coordinate system. It's the same as -2, 2, -3, -2 in terms of the Cartesian or rectangular coordinate system. They're located in the same position. So instead of using this one, we know XY is much simpler to find out the point, so that you can find out this is from the, from the x-axis, this is from the y-axis, this is from the z, so that back and forth work gonna help you to find out the better position of the points. Okay, so that's how we're gonna do in 2.7, like converting between them. One more example. So keep in mind that formula we already discovered a long time ago. And one more example. In this time, I want to convert, right? In this time, xy is given. And then I want to convert it to R theta Z in terms of the cylindrical. So what we know, R squared is x second plus y second. In other words, R equal to radical x second y second. So we can find out the R radius in terms of the cylindrical coordinate. So x is 1 square, y -3 second. You will get radical 10. And then we also know tangent theta is a y over x. So y is a -3, x is a 1, so -3. That means tangent theta is a -3. I'm looking for the theta. It will be tangent inverse -3. You can convert it to 5.03. This is a radian. So what does it mean? We just change 1 comma -3 comma 5. It's the same as radical 10, 5.03, and z is the same thing in terms of the cylindrical coordinate. So they're locating the same thing. So depending on the question, finding a rectangular coordinate could be much helpful to find out the information. Depending on the question, sometimes the cylindrical coordinate points will be much efficient to solve the problem. So we should know back and forth both how to find out them. Okay. All right. So let me keep going down slowly. So let's go to the couple more practices. So what's going on here? I wanna just take a look at more information. So we just talked about it. X, Y, Z. You can convert it to R theta Z in terms of the cylindrical. So actually, what that mean? If I have a theta pi over 4, actually, what does it mean, right? So everything, I'm gonna explain it. So when the angle theta is held, right? So which is pi over 4. And then this is constant while R and Z. So this is the R comma theta Z. The theta is given pi over 4. We don't know what the R and Z. So R and Z are allowed to vary. It could be any number, right? So if you have only angle, okay, doesn't matter X, Y, R and Z could be any number. It could be smaller radius, it could be larger radius, but you will find out the plane anyway. So theta equal to some number, you will find out the plane, which looks like this. So just we are observing what that means. Theta is a given, you will find out the plane, okay? So let's take a look at, keep going. The next one, what does it mean? R squared plus Z squared equal to 9. So this is very awkward. We have a R, we have a Z, like both the Cartesian and cylindrical coordinate system, kind of like they're mixed. But what we know, R squared, since R squared equal to X squared, Y squared, we can sub this one into the R squared. So therefore, this equation means X squared, Y squared plus Z squared equal to 9. This is literally what? This is a sphere equation. If you remember, center at 0, 0, 0, radius is 3. So that's why you will find out this is sphere shape of that equation. So I'm trying to show you what this equation actually creates, in terms of the graph or in terms of the shape. So you can, since we know how to back and forth between Cartesian and cylindrical, you can explain it. Okay, this equation actually going to be a sphere. One more. So the next question, we have only Z equal to something. So Z equal to R. Wait. So radius is going to be the constant. So this means Z equal to some number. Wait. All the way up. If Z equal to some number, this plane is going to be parallel line to XY plane as you see this. So therefore, we know X equal to some number is a parallel line XY plane. That's a characteristic of each 3 different plane. So let's think about it. As the value or as the Z increases, R also increases, correct? R also increases. We know that this Z equal to some number is going to be parallel line. And then they're going to find out the characteristic. As Z increases, R increases, or Z decreases, R also decreases. So therefore, Z equal to R, so there's a radius. So we have a circle, and then circle, bottom. What happened? As R is increases, Z also increases. So this is going to be cone shape. That's why. Okay, it's the same thing. If you are decreasing Z, the radius is it's a symmetry. So if you have Z increases, R increases, Z decreases, also R decreases. So therefore, in this time, you will find out the cone shape like that. That's Z equal to R. Okay, so I'm just observing what each equation gonna be look like, so you can think about more information between Cartesian and cylindrical coordinate system. Okay, so it's a very, very understandable topic because we learned those 2 equations. So I'm just leave it this question. I'm not gonna do this one. You can try this practice yourself. So I just show you how to convert rectangular to cylinder, or cylinder to or cylinder to rectangular. Okay, so this one actually, this question is a little bit wrong. We can find out the rectangular. This is a cylindrical. So find the cylindrical if you know the rectangular. So try this example we just practiced, okay? I'm gonna do more example in terms of this concept. So let's do number 4. Actually, this is something what I wanna do. So, okay. So here I have a 4r second plus a z second equal to 16. So this is like mixed between cylindrical and Cartesian, because we see r from the cylindrical and we see z in terms of the Cartesian. So, or it could be just, cylindrical equation, but I want to know the shape. I want to know the shape. So which quadratic surface you will find? That's actually what I'm looking for. Okay, this is actually cylindrical equation because it has r theta z. So it's hard to find out, what the shape look like. So I'm going to convert this cylindrical equation to, rectangular, the Cartesian equation. Yes. So that Cartesian equation, when you convert it to, you can choose which surface, equation, corresponding to each other. So if you remember 2.6, we talk about quadratic surface. There are a couple, table we learned. And then once you convert cylindrical equation to Cartesian, then you can find out one of the quadratic surface equations. So let's do that. So since we know r squared equal to x second y second, so 4x second y second plus z squared is a 16. So it means 4x distributive property equal to 16. Now I'm going to divide it by 16, 16, 16 everywhere. So you should get x squared over 4, y squared over 4, z squared over 16 equal to 1. So this is one of your quadratic surface, and then go back to 2.6, find out the matching, equation. It is going to be ellipsoid. So this equation is a cylindrical equation. We don't know. We don't have no idea, what graph or what shape you're going to find out from this r theta z cylindrical equation. So once I convert it to the rectangular equation in terms of x, y, z, so we found out beautifully ellipsoid. So this is one of the quadratic surface equation you can find out. So that's how you're going to find out, the matching image and equation, from the cylindrical equation as well. Okay, so this is the same thing. We know that this is a cone shape. As z increase, r increase. So that's the only way. We have x, y, z. So as r, right, the z is here. As z increases, r, the radius of the circle, also increases. So this is the circle. I'm sorry, this is the cone shape we will find out. Okay, so we can think about it. I'm going to keep practicing like this. Let's go. Okay, now in this time, I'm giving you already rectangular equation. So this is already rectangular equation, right? So I want to find out, what the shape look like. So we already know, but they also want to find out the coordinate equation as well. So this one is going to be, r, since x second, y second, it's r squared. So this equation will be r squared plus z squared equal to 36. Again, this is a cylindrical equation, and it's a really difficult what the shape look like. The rectangular equation is better to, think about the shape, what it look like. So we already know this is you can think about it. This is a sphere equation where at center 0, 0, right? And the radius is a 6. So that's the sphere equation. And then this equation is the same as r second plus z second equal to 36 in terms of cylindrical equation. Okay, so you should figure it out back and forth, okay? One more practice. Z equal to 12 minus 4x a second. So you can find out, what the, quadratic surface equation look like. So you can, move all. I'm going to change the order. So this is the same as a 4x a second, 4y second, z, and then equal to 12. I'm going to divide it by 12 everywhere. So it is going to be x second over 3, y second over 3, z over 12 equal to 1. So if you go to the, one of the quadratic surface, it is going to be corresponding elliptic paraboloid shape. Okay, so check it out, 2.5. This is the corresponding equation, but I want to also convert it to the cylindrical equation, right? So that's what they're asking you. This is the, Cartesian rectangular equation. Let's convert it to the cylindrical. So we know we have a 4x a second. So we already know that it is 4x a second plus 4y second plus z equal to 12. And then I can find out the common factor for. So 4r squared plus z equal to 12. This is a cylindrical equation, and it creates the same shape, elliptical paraboloid shape. One is a rectangular, another one is a cylindrical. That's it. Okay, so I think this is not really complicated concept. As you know that, the point can be located in terms of x, y, z, but also r, theta, z. So this is in the three-dimensional space. So you can find out, surface, quadratic surface equation as well that are corresponding to both rectangular and, cylindrical equation. So that's what we practiced so far. I'm going to keep going. Now I'm going to talk about the spherical coordinate system. It's a very similar. Here, I have x, y, z rectangular. I'm going to convert it to spherical coordinate. In this time, we're going to use a p, theta, and a little bit of weird function. I'm going to show you how to read it. So this is the symbol. So here is the thing. P, we read it real, okay? Or you can just read it as a P, that's fine. It indicates that distance between P and origin. So there is, the points in terms of X, Y, Z. So this P indicate that the distance between origin to here. So same function like a radius, okay? But sometimes you're not always finding out the circle shape. Sometimes it could be cubic, it could be more different shape, pyramid shape. So the distance from the origin to the point, you're gonna find out the P. So I'm gonna just show you a little bit of what is the difference. So let me just write it here because I want to give you better understanding. So we have a cylindrical r theta z, and then we have spherical point. This is p theta. This means the radius of the circle. So in cylindrical coordinates system, your shape is pretty much all like a cylinder. This is always like including the cylinder shape or circle cross-sectional image. Okay, that's why R indicate the radius of the circle. Theta, you can find out the angle, inside of the circle, and then Z is just number from on the Z score. Spherical is a different. You're not gonna be always find out the cylinder. It could be pyramid shape. Okay, so that you want to point out here. So find out the origin to the distance. So the P, this indicate the distance between origin to what? What did I say? Origin to the given P, the point. Those are two systems. You can always convert it to the Cartesian XYZ. This is Cartesian, or we call rectangular coordinate system. And then if you have XYZ, this is better to graph or draw the shape, because we know all the corresponding surface quadric, or quadric surface, that's better. Quadric surface. Okay, so that's the relationship. Cylindrical is cylindrical coordinate system, gonna create is described by the cylinder, shape. Spherical could be, definitely cylinder, but also other shape. And then both of them can be converted to Cartesian rectangular, and you can find out more specific, shape of that, because if you know XYZ, it's much easier to find out the corresponding surface, quadric surface equation. So think about the three relationship. So the question is going to be back and forth, convert it to that or that, find out the matching image. So we are talking about everything, those are three: cylindrical, spherical, and Cartesian rectangular. So let me go up. So remember, spherical, P is a distance between the origin to the P. Theta is definitely angle, right, that they're creating. It could be cylinder or it could be other shape. And this is the pi, that's how you read it. And then this is the angle, between Z, formed by positive Z and the line segment OP. So we have OP, this is segment. And then the angle between Z, this is a Z axis. So particularly this angle between the segment OP and Z, we call this is the pi. And then we're going to find out this one in spherical coordinate system. Okay. So that's a different thing. And then if you remember, I'm going to highlight though. So this data are not equal. So this data is the angle between OP, the segment OP, right, and the Z axis. What is this data? This is the angle between radius, right, between the radius and the x-axis and x-axis. So they have a different angle. It's not the same angle, just we are using the same symbol theta. Okay, so that's a different thing. Okay, usually pi is a given, you don't need to worry about it, but this is the the number as pi and theta is getting larger and larger, and this is also going to be larger. So I will show you that more. But remember, this is the structure of a cylindrical and spherical coordinate system. And then we're going to follow the next one. So if you know XYZ, you can convert it to the coordinate system or back and forth. So X is going to be this pi, the real, times the sine pi times the cosine theta. And then Y, so you don't need to memorize them. It's going to be given. But it's a pretty similar from the cylindrical equation. We're going to use this, okay? All right, so let's really do the problem. So keep in mind, this is important. I already copied this here, so you can find out the same equation right there. So I'm giving you the spherical coordinate point. So this is P, the distance between origin to the P. And then this is the, theta, the angle between Z axis and OP line, the segment OP. And this is the pi, the impact of your P and theta. So just keep in mind, okay, we want to convert it to the either or actually both rectangular and coordinate. So let's do the work. Step by step, we're going to use this formula. So x is going to be p 8 times sine pi over 6 times cosine theta. So this is a pi and this is a theta. So we have a pi over 3. So use a decimal, you can find out 8 times 1 over 2 times 1 over 2, you should get 2. Y, same thing, 8 times sine pi, which is a pi over 6 times sine pi over 3. So 8 times 1 over 2 times a radical 3 over 2. So you should get 2 over radical 3. The z is going to be pi 8 times cosine p times cosine pi, which is pi over 6. So you should get 8 times radical 3 over 2 for radical 3. So what happened? 2 comma 2 radical 3 for radical 3. This is the rectangular system, the Cartesian. So we found out the rectangular coordinate system. Now, if you know the rectangular XYZ, it's much easy. We know how to convert to the cylindrical equation. So now I'm going to convert it to from XYZ to the cylindrical R theta Z. So we know a couple equation right there. You can use one of them. So I do have XYZ, and then you can convert it to R theta 0. So can we do that? So what are you guys going to do? R theta 0, R theta 0. So we know, let me go up the equation because I don't memorize that too. So if you go to the coordinate, R equal to radical x squared plus y squared. And what we know, tangent theta is y over x, and then z equal to z. So what happened? We're going to convert it. R equal to x 4. This is xyz, and then 4 times 9, 4 times 9, 36. So this is going to be radical 40. So R is going to be radical 40. Am I correct? And then you can keep on going. The next one, what is it? Tangent theta. So tangent theta equal to y is a 2 radical 3 over 2. So tangent theta is going to be radical 3. So theta will be tangent inverse radical 3. So tangent inverse radical 3. So you can convert it. I don't know what the number is. Oh, sorry. Let me calculate it, decimal. So tangent inverse of radical 3. So that's going to be the radian 3. So 1.04 radian, right? And then z is going to be same for radical 3. So that's how you can find out the cylindrical coordinate system as well. Does it make sense to you? So think about it. This is not really crazy work, not at all. So you can do this work. I converted from, this is the spherical coordinate. You convert it to the XYZ rectangular. Once you know rectangular XYZ, you can convert it to the cylindrical. So check this information. All right, so let's keep going. Let me go down one more example like that. Okay, convert the rectangular. So this is XYZ. Now you're gonna change both spherical and cylindrical. So what are you guys gonna do? We know all the equation. So convert from XYZ to, what do you want to do first? Let's convert it to the cylindrical. Yes. So R theta Z. So XYZ negative 1, 1 radical 6. So R is going to be x second plus y second. And then tangent theta is y over x. So we can find out the R. 1 plus 1 equal to radical 2. Tangent y, 1 over negative 1. So theta, so we are looking for theta is going to be tangent inverse. This is (-1/1). So -1. So you can find out the tangent inverse. So theta will be 3 pi over 4 if you just change it to that. So this is going to be theta, and z is going to be same as a radical 6. So that this is going to be radical 2, 3 pi over 4, and radical 6, right? So now you have, you know, x, y, z, and r theta 0. So you can convert it to spherical. So what do you want to do first? We practice that, right? So a little bit long formula. So if you know, go up, we're going to use this, p theta this. So we're going to find out p equal to x second plus y second z squared. So if you calculate it, 1 plus 1 plus 6, radical 8, that's going to be p. And then we do, what was the other equation? Tangent theta is a y over x. So y, same thing, 1 over -1. So if you can calculate the theta will be, so in this time, it's the same theta, tangent inverse -1, 3 pi over 4. The last one, in a phi, the phi, what do I know? Cosine. So cosine, we have a cosine. This one is what they say, z over p. So we have z over p. So z, we know radical 16, radical 6. P, we just find out the radical 8. So this is the angle we are looking for. Cosine inverse, radical 6 over radical 8. So you can convert it that. So it's going to be pi over 6. So therefore, in the spherical equation, you found out radical 8, 3 pi over 4, pi over 6. This is the spherical coordinate system. This is the rectangular. This is the coordinate, cylindrical coordinate system. And then this is the spherical coordinate system. Okay, so you got this. You got this back and forth. Okay, so I'm gonna just do a couple more examples, just couple more. Let's take a look at a little bit complicated question. Okay, here. So identify surface, you know, in the spherical coordinate system. So this is like a little bit ugly, right? There's a little typo. So there's no D, we just have a P. So in this question, they want to know, this is the spherical coordinate system. I want to convert it. First, you need to convert it to X, Y, Z. Then you can find out what kind of quadratic equation. So that's what they're asking. Which quadratic equation you will find out. So we are going to convert this sphere coordinate equation into the rectangular equation. So step by step, P equal to sine theta, sine P. I'm going to multiply P on both of sides. So you should get P second. I'm going to put the P first. Sine theta, sine pi. And then what else do you know? If you go up, P is the same as P squared is the same as X second, Y second, Z second. So I can say this is equal to X second, Y second, Z second, because I want to convert it to X, Y, Z. And we also know, right? Our what else do we know? We also know go up sine P. So here, if you go up, P times, right? P times sine theta and sine pi, this is going to be Y. So we have the information, same thing. So this is going to be Y. Dun, 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 dun. So let's do the work. So that means X second, Y second, I'm going to move this around, minus Y plus Z second equal to 0. So we are going to solve this one. X second y second y plus minus, because I want to find out the binomial factor. So what happened here? Invisible 1 divided by 2 second power. So you have a 1/4, 1/4 adding and minus. So that means we have x second, y second, y plus 1/4 minus 1/4. It's anyway 0. So you don't need to worry about the balance. It's the same. Now what? This is the binomial factor. X second, y plus 1/2 second. And then we have a z second. I'm going to move this one to the other side. 1/4. Are you okay with that? So what is this equation? This is your rectangular equation. This is a sphere, right? Equation, center at 0, 1/2, negative 1/2, 0. Radius is 1/2. So you can find out the corresponding quadratic equation. That's it. Okay? So you can do this type of question. There's more practice you could try. I'm going to do a little bit of question. So this is the most important thing question, right? A little bit. Yeah. So I hope you guys are understanding what we are doing. We are dealing with 3 different coordinate system: rectangular, cylindrical, and spherical equation. They can be back and forth because they're indicating the same location in 3-dimensional space, just different perspective. So, also you can find out the specific shape of that, equation when you're finding out the corresponding quadratic equation like this question. Okay. So this one you can try. We already practiced. You can convert rectangular to spherical or back and forth. Find the spherical if you have a rectangular. Try this one because we already have all the formula. I'm going to do 2 more examples. Hold on. So I just want you guys to observe one more time. So we talked about it. P means the distance between origin to the point. So P means the distance between origin to the point. Okay, so in this time, the distance from the origin to the point that you want to get, that this is the point you want to reach out, right? So this is the P, this is the origin. So the distance is 7. That's what they're talking about. Okay, so I just want you guys more visualizing information. What does it mean phi? So we talked about it. This is the angle. This is not the angle. This is, I just want to share with you. Many people confuse. This is always the angle, the upper angle of cone shape. I know it's a little bit weird, but just think about it. The angle, this is the angle between pi/4 and the z-axis. Okay, so for example, if I have a cone shape, we have a xyz. So there's an angle z. This is the pi/4. So that's a little bit tricky. So you don't need to worry about this one. I'm not going to ask you what the pi mean, but usually it's going to be given. Okay, in the spherical equation, pi will be given. Also, we know the formula. Okay, so you don't need to worry about, this is just the angle, that is a given between the z-axis. Okay, the last one. Oh, this one, we also did it. So this is the equation we just practiced. Number 7. Okay, you can convert this one so you can find out the shape, which is surface equation you're going to find out. So if I try to do it one more time, you're going to multiply p both of square, sine pi cosine theta. So this is going to be x second, y second, z second. And remember, for p times sine pi cosine theta, in this time that is going to be 4x. So that means x squared minus 4x, y squared plus z squared equal to 0. You're going to find out the same thing. Find out the constant that you are going to adding and subtracting. And y squared is z squared equal to 0. So 4 divided by 2 and square. This is a 4. You're adding minus 4 both. And then what happened? Let me just make a little bit of space. So this equation, if you bring x second minus 4x plus 4 minus 4. And then, gotcha. This 3 is going to be x minus 2 squared plus y squared. And then negative 4 is here. So what does it mean? This is another sphere equation where center 2, 0, 0, radius is 3. So in this time, we found out the sphere equation, sometimes not, right? Depending on the given equation, so you can practice more, okay? So I have the same question here. You can practice, right? So this is all the, surface or rectangular equation. Simply, this one you can convert it to what? This is going to be the, sphere equation 0, 0, 0, radius is 6. We know that x second plus y second plus z squared, that's a p. So p equal to 36. Actually, p second power 36, that means a p equal to 6. So this equation is spherical equation. This is going to be rectangular or quadratic equation in terms of x, y, z. Does it make sense? And you can do the same thing. This is already, we know, quadratic equation. You can go back to the cylindrical, spherical equation. You can do it. So I'm going to do this one, last one, because this one, I just want to show you quickly. So z equal to 12 minus 4. I can factor out negative 4, so x second, y second. And then if you remember, we know x is p times sine pi times cosine theta. Y is p times sine pi sine theta. We know this equation, so you can convert it to here. Then what are you going to get? Z equal to 12 minus 4. X is a p sine everything square, so p square sine square pi cosine square theta plus, I need a space. And then plus y square means p square sine square pi sine second theta. So now you can expand everything. So z equal to 12, 4 p square sine square pi cosine theta 4 minus 4, because negative 4 is a distributive property. So negative 4 p square sine square pi sine square theta. Correct? And then I can combining like term 4p square minus 4p square minus 4p square. And what else? Sine second pi, sine second pi. I can factor out. You see that? So z equal to 12 minus 4 p square sine square pi, and cosine here missing second, cosine second plus sine second. According to the trigonometry formula, we know this is going to be uno. So z equal to 12 minus 4 p square sine square pi, because 1 is the same. And then what happened? Z also, if you go up, I'm going to write it here. Z is same as p times cosine pi. So I can convert it. This is p times cosine pi equal to 12 minus 4 p second sine pi. I can change the order. So basically p times cosine pi plus 4 p square sine pi equal to 12. This is the spherical equation. You can convert from that rectangular equation. So again, you can do back and forth. So that's all about it. So 2.7, I want to really emphasize on how to convert, right? From cylindrical to rectangular, or from rectangular to cylindrical. Another one is from spherical to rectangular, or from rectangular to spherical. So that you can think about all the relationship, those are three. And then as you remember, I think I show you the map here. This is the really, really, clear to think about all the relationship. Okay, so that's all about it. 2.7. Yay, we finished chapter 2. Can we celebrate for a second? Woohoo, I know. So you guys been doing awesome, awesome, awesome. You guys are amazing. Calculus 3 is not really easy topic. There are a lot of abstract concept, but you guys have been pretty doing well, right? So please read textbook, because I know some of you guys are planning to go to engineering major, physics. The more you read, the better you have, right? So please read the textbook. My lecture note is all the extra concept from the textbook, based on the textbook. And also we have embedded video. You can study and watch more. Then you can build up a better confidence to complete 2.7, all the quizzes. And as you know, whenever you have question, go ahead, discussion board, okay? So I will stop recording at this moment. I will see you guys in the next video. Thank you, everyone. Bye-bye.